Hello, everyone. Welcome to the episode 3, right? Let me just arrange my presentation entirely. I just missed. Sorry for this. So, welcome back to From Zero to Agentic AI. This is episode 3. And in the previous two episodes, we defined what an agent is and we drew a sharp line between agents, chatbots, and traditional software. Today, we are going inside the agent. We are going to look at the one mechanism that every single AI agent runs, from the simplest reflex bot up to the most sophisticated coding agent. It's called a perceive, think, and the act. Perceive, think, act, loop. Three verbs. One loop means it's a three verbs, but they are in the one single loop. So by the end of this episode, you are going to see this loop everywhere, in coding agents, in voice assistants, in browser agents, in robots, right? So it's like a same machinery, but different inputs and the outputs. So now let me start here with a one moment of your life. So here you are sitting. Let's imagine that you are sitting in a coffee shop. You are reading something on your laptop, minding your own business, and suddenly there is some like the crash behind you. Somebody drops a ceramic cup. So what happens next, right? In about a quarter of a second, three things happen inside your brain, right? First, your ears hears the crash. Your eyes flick towards the broken pieces. So what is that? That's actually a perception, right? Then your brain decides what just happened and it decides what to do next, right? And then what you do, you simply take the act, right? Means you simply go in action. You will just simply turn your head, you might get stand up from your place, or you just go and help that particular person. So what happens? You just simply ran a loop inside your brain. That's actually an unconscious activity. But yep, simply, this is what we known as a what? Perceive, think, and the act, right? So every intelligent system we can see, whether it's a biological or artificial, runs some version of this loop. And here we are going to dive a more deeper into the AI version of it. Now I'm going to say the one entire architecture in a one single sentence, right? So what is this? An AI agent is someone which continuously observes the environment, right? Reasons about what is happening, right? And what to do. And according to that reasoning, it takes the action that change the environment. And this process happens continuously, right? This process happens continuously. So here, when this inside entire process, right? There are multiple things includes, right? There is a tools, there is a memory, there is a planning, there is going to be a multi-agent system working inside the loop, there is going to be evaluation, there is even the safety being considered, right? So every single one of this thing sit inside this loop on top of each other, right? So in rest of this episode, right, we are going to break each word of it apart, right? So just remember this definition. It is a spine of this entire episode. Now, here we can see one thing, right? It's a one simple plain diagram. First box is perceive, second box is think, third box is right. And the last and the fourth box you can see, this is what an environment is, right? And this arrows, here you can see, they are the most important part of this entire diagram, right? So here it's an act, right? What is happening? Here it's an act, right? It starts with the act. Your agent takes the action. Then there is an environment, somewhere over environment over here, right? An environment gives some observations, right? So things starts over here. Your agent perceives, right? If it is reading something that it's read the input given by the real users. Then the agent thinks, what is the next step to choose? What is the next action to take? And then the agent take the act. It produces the output that actually changed the things what it was previously, right? So the agent, this agent does not live along a straight line, right? It's not like that you just pass an input and it gives you an output and it's done, right? If it do this, that it's nothing, it's a simple chatbot. So this agent is something that lives inside the loop. It keeps cycling until the task is finished or until something stops it. That feedback loop is what separates agent from one shot models, right? So keep this picture in your brain, okay? Take the screenshot of it. Now let's go to each of this thing in detail, right? We start with perceive. So what is a perceive? Perceive is the act of taking a raw input from the environment and turning it into something that agent can actually reason about, right? So here you can see, right, a different example like what happens in the perceives. So if you have a chatbot agent, so what chatbot agent perceives? It perceives the text message from a user. If you have a web browsing agent, what does it perceive? It perceives HTML, it perceives screenshot, it perceives the page titles, it perceives the URL. Likewise, we have a coding agent, voice agent, or the robot agent, right? So robot agent goes for pursuing the camera frames, lidar, and the touch sensors, right? So the agent never perceives the world directly. It always perceives a representation of it, right? That representation is everything. Get it wrong, and the whole loop is poison. So, how you are making the agent to perceive whatever input you are giving, that is very, very important. Now, let's get it more concrete, right? So, what does an observation actually look like, right? So, an observation is something, right? It's just a tiny piece of information that agent just received. So if some user is doing the message, it is like a book me a flight to Delhi on Friday. Then you go with the tool output, that search return key results. You get an error. API call failed with 429. You pass the file, requirement.txt, or maybe that particular file contains something like 12 dependencies, right? So observations are the what? Agents only window into the world. If something wasn't observed or wasn't remembered from a previous observation, it does not exist to the agent. This is why memory and context engineering matter so much. The agent is operating on what it sees, not on the world itself. Now, let's move to the second stage. That's a thing. So, think is where the agent takes everything it knows and picks what to do next. What goes in? Four things, right? The latest observation, hold on just, right? Sorry. So the latest observation, the agent's memory, the goal it's pursuing, and the surrounding context. And what comes out, right? Something like a decision, right? Usually, what is the next action to take up, right? So I can say that the output is not a reply to the user. The output is a choice, right? When something goes in the agent takes the decision, right? It makes a choice that what tool to call or what to do next, right? And basically for LLM based agent, right, this is a literally a forward pass, right? That one information is going from one state to another state, right? And the user is basically a getting a final output as an action from the agent, right? So here I will simply say this line may be hard for few people to understand, but thinking is a structured next token prediction applied iteratively on a purpose. So at every iteration the agent makes a certain choices. Now let me crack open this thing in a very detail, right? That how the thing, right? We talk about perceive, think, and the act. So what happens inside the thing? Four thing happens. First, it understand what was the observation during the first step, that is a perceive, right? So if you are passing a file, it will pass what was received, right? It will resolve what it means for the correct context. Second, it will recall the relevant knowledge from the previous observations, right? It will try to recall the previous knowledge. And the agents are technically running all the LLMs. So they have something called a parametric memory, right? Memory coming from the tools, memory coming from the external database, right? In the same third point, right? It will check against the goal, right? Am I closer than what I was previously? Have I completed this task? Or do I need to change the strategy to complete this given task? And in the fourth, we need to select an action, right? That is, during the think step, the agent will itself think, right? That which available tools to choose, which subtask to perform right now, or which response will be better for the user, right? And the third stage is what? Act. So, act is where the agent produces the output that actually changes the environment. So, there are broad categories for the action. So first is a communicate. The agent talks to the human systems, just like the chat GPT we have. We are interacting with the chat GPT. So chat GPT is not a chatbot anymore. It's an agent. It replies to us. It writes us an email. It even posts a message on behalf of us. Second is a use a tool, right? So this agent calls out certain capability. It will hit an API, it will run a web search, or it may execute a certain code. Maybe you people have explored the codex, or maybe you people have explored web search. Everybody knows that how the web search work. This is very much common in the Gemini. Third is the touch data. The agent read and writes the world state, right? It will read a file, it will write an output, or it will query a database. And the fourth is what? Control flow. The agent decides in this X step that what needs to be done next. Do you want to call another agent? Do you want a human to request something, right? Or do you want this loop to restart again and tries, right, and retry? So here I want to say something, right? Here I want to explicitly say, right, this whatever things are happening, right, between perceive, think, and act, these things are not externally visible, right? Agents are technically a token burning machine, right? And they always have one thing, right, during the action step, that they always think before answering, right? So thinking to answer, right, is also an action. And this thing, it's an internal one. But this thing counts, though we cannot see. Now, here is a quite fast comparison between chatbots and the agent. So chatbots are very simple. It's one simple input, it will give you an output. Nothing changes. But when you are working with an agent, right? So output is actually what a side effect, right? Some file will get written. A certain API will be called when you are talking with an agent, right? Your agent will go and will browse the internet. Your email will be sent. Your certain code will get executed, right? So, but one thing is we need to keep in right, that certain changes done by agent in certain time or in certain cases, it's irreversible, right? Maybe you have passed a bad prompt, you can take it back, but you cannot take back the bad email which you sent, right? So here that comes a portion of an agent safety, right? And this is the fourth element of an agent now, right? That's an environment. It's an outside of an agent. That's we. We are the environment for the agent, right? Our internet is the environment for the agent. Whatever outside the perceive, think, and act loop, that's an environment for the agent. If you are building a rec system, if you're asking the agent to search, then it's an environment, right? If here we have segregated into four parts: digital, conversational, external services, and the other agents, right? So in digital, it's files, browsers, code, and databases. In conversational, that's a human, right? We are the human. We are looking at the message and texting them back. Then external services, which we always call like APIs, devices, and third-party platforms. And the fourth is an agent calling in another agent, right? So we have something called the multi-agent system. So one agent talking to another agents are an environment for each other, right? And this environment responds to an action taken by the agents. And this agents perceives those particular action from the environment. That's an observation from them, right? And this loops continues. So this is an example, right? This is an example, a real run, right? He full cycle to finish the one task. That's the title I have given. So here we have a task, right? That the find top three trending AI papers from today and summarize them. So it starts with first, that's a pursue. So it receives user task as a text input. Then in the second step, it will think, decides to use a web search tool. Then in third task, it acts. Call search with trending AI papers today. So here we can see one loop is completed, right? Then whatever the AI papers they have got over here, right? Any trending AI papers, those AI papers will be pursued by them, right? It will receive the results. In the result, the agent will receive something like titles, links, and the snippets. Then it will decide, right? It will again think, let's decide to fetch the full content of the top three link. Then again it will act, it will fetches each URL, pursues. What it will do, it will receive the page content, right? In think, it's decide to summarize each paper. And in the act, it will generate the summaries and it will return the full and final answer. So that's a three full cycles of an agent running over here. That's a perceive, think, and the act. Now, this is the most common misconception which I want to remove, right? Agent think once and they response no. If they are thinking one and responding, then it's a chatbot model. They are not the agent model. So, see, multiple things can happen inside chatbot, right? Here I have highlighted the 4 points. It may pursue something unexpected and reconsider the plan. It may act, fail, and it will try a different approach to reach at its goal. It may realize mid-task that it needs more information. It may finish a subtask and then start the next one. So I can say this is good and this is bad. You do not know what are the number of loops it is going to take during the final iterations, right? It completely depends on the seriousness of task, right? Complexity of task you are doing. So this is the difference, right? One loop or many loop, right? So how many times does a loop run? I try to give an answer over here, right? If it's a chatbot, right? If it's a one step or single step agent, right? There will be a one single loop. In multi-step agent, it will run many times, right? Here you can see an answer, right? Answering a factual question, like what is the capital of France? That's a one-step thing. It's obviously we know it's a Paris. But if you ask that is to book a flight for Delhi, then the agent has to take the multi-steps. It has to search for the cheapest flight. It has to just search for the cheapest credit card. It has to search for the best offers. It has to search for the best time. It has to search for everything, right? So that's where it gets complex. In tool use, it will just simply use the one single tool. In multi-step agent, there are multiple tools to be called. Complexity and risk is very low in single step agent, but in multi-step agent complexity is high, and in certain cases risk are irreversible. And in most real world cases we can always see that the agent need a what, a multi-step execution, right? Agent need a what, a multi-step execution. So what makes this agent smarter, right? See, agents existed 10 years ago, right? They were even also there in 2016. They were also there in 2008. But here something called an LLM, right? We call it as a large language model, which makes it more better. It allowed to handle the more novel situation. So before LLM, what we had? We had a what kind of an agent? We had an agent which had a certain handcrafted rules. We had a particular narrow machine learning model to handle one particular kind of a task, right? There was no generalization than beyond anticipated, right? So whatever the rules are there, we have to behave according to those rules. There were certain messy inputs coming, then the system will start to break. But when the agents came, when the LLMs came, right, The agents were able to handle complex situation in a very well manner, right? They were capable of understanding the natural language of observation, right? Even extremely messy ones, right? It will reason about a situation that it wasn't explicitly trained for. It will generate a flexible action plan in the natural language. It will adapt to mid-task on a tool feedback. It's even a human feedback. So what is this? Just like the human have a brain, this LLM is like a brain for the agent, right? And the rest is just the infrastructure revolving around this LLM. So in what we are discussing, right? Perceive, think, and the act. So in this perceive, think, and the act, this LLM is a think part, right? This LLM is a what? Think part. So this is a good example, right? That every real agent, right? Like how it works. So if we talk about a coding agent, what it will perceive? It will perceive code, it will perceive errors, it will perceive the test outputs. It will think with what? It will think with LLM. It will think with code execution. And it will act on file system and the terminal, right? Then, see, these are the examples we have taken of, right? We have an autonomous task agent, we have a chat assistant plus tool, we have a browser using agent, we have a voice assistant. Every kind of agent will perceive things differently. It will think according to the purpose and it will act on. But just see, for every task, we need a different LLM. For coding agent, we need LLM. For autonomous task agent, we need a general purpose LLM. For chat assistant, we need a frontier LLM. For browser using agent, we need a vision language models. For voice assistant, we need a natural language understanding plus dialogue model, right? Every LLM for every task is different. So key thing over here, which we need to keep in mind, that at every step, our agent can break. When we are pursuing, our agent can break if we are giving it a noisy input, if it has a missing context, or if we are giving it as an hallucinated observations, right? Doing a thinking, if the noisy input or some missing context are given, our agent will start to have a wrong reasoning. It will do a wrong tool selection, or it might drift from its original goal, right? At certain times, we have discussed earlier that it may draft a wrong email and send it, right? There can be a certain unintended or a misunderstood task which they did. That's why we have an environment, right? We call it an HITL. That's what human in the loop, right? So human in the loop is very necessary just to monitor that our agent is not taking a wrong decision. And the our most important thing, that these loops are technically an infinite loop. It's certain many times stuck in the subtask. Context are lost over time, right? So good agent design is very much important. Anticipating failure at each stage is very much important. This is what we are going to cover in the episode 29. So 6 things to walk away with. That's perceive, think, act, the loop, LLM rule, and the iterations, right? These are the six learnings we have today. So next in the episode 4, we will be understanding the types of agent, right? So we will make the thing easier. We will even make the thing smarter. So we take the perceive, think, act, loop, and one question, that what happens when the think step becomes more sophisticated. Simple, reflex, model based, goal based, utility based. Each is a different design decision about what goes inside the box, right? So first, you people have a homework. I hope you people do it ethically. Then here I leave one question for the discussion. And last thing, subscribe so you don't miss the episode 4. Thank you. Thank you, everyone.